All right, so in this video, we're going to talk about circular motion, okay? With circular motion, we've got two concepts we need to worry about or think about here. So the first one's going to be angular speed, okay? So how fast is the angle changing, okay, relative to time? And the second thing is the linear speed. So even though the object's traveling in a circle, we need to think about the rate at which the distance traveled of that object is changing over time, okay? So first thing, angular speed, we got a formula here. This little symbol we call omega, okay? It kind of looks like a lowercase w here, but it's a Greek letter for omega, lowercase omega, equals theta, which you've dealt with here. Theta is going to be that angle in radian measure, has to be in radian measure. If it's in degrees, you have to convert, okay? Divided by time, all right? Linear speed, okay? Remember, velocity is always going to be a distance traveled divided by time. Well, distance traveled when we're talking about circular motion is going to be that arc length, okay? We're going in a circle, so we just learned about how to calculate the arc length covered on a circle based on the radius of the circle and the angle that's being cut there, okay? So arc length S equals radius times theta, and again, theta has to be in radians. All right, so this S here stands for arc length, not something else, so just make sure you're aware of that, okay? In example one, we've got a tire, okay? So we all know how tires rotate. It's always going to maintain contact with the ground. All right, so a car tire with a 16-inch diameter makes 120 revolutions every 10 seconds, okay? Now we want to find the angular speed of the tire in radians per second, okay? So let's kind of go through the process of doing that. So in 10 seconds, the angle is going to change 120 times, and each of those 120 revolutions covers 2 pi radians. Remember, one full revolution is 2 pi radians. So if we're making 120 revolutions, okay, that means we're going to multiply 120 times 2 pi, all right? So our theta here is going to be 124 times 2 pi, or 240 pi radians. So that's how much the angles changed over the course of 10 seconds. Okay, so we've got our formula. Omega equals theta divided by time. All right, omega is going to be our angular speed in radians per second. Theta is radians, time is in seconds. Okay, so now that we know what theta is, we can substitute that in here for theta, 240 pi radians. Time was given to us in the problem, okay? Time is 10 seconds, so that's why my denominator is 10 seconds, okay? So the angular speed of this tire in this situation is going to be 24 pi radians per second, okay? This is an exact answer, that's why I use the equal sign. Now, 24 pi might not mean a whole lot to you, so let's make this into a decimal. So the angular speed is approximately 75.4 radians every second, okay? All right. The linear speed, remember the linear speed formula is velocity, or linear speed here is the arc length divided by the time, okay? So in order to find arc length S, we need to use the formula that we learned previously. S equals R, or the radius times theta, okay? The radius is 8 inches. Remember, the car tire was given to us in diameter. We have to cut that in half to get the radius, so the radius is 8 inches, okay? And the angle, we already found the angle in the previous problem dealing with angular speed, so the angle that we're dealing with is going to be 240 pi radians, okay? So the arc length then is going to be 8 inches times 240 pi. So that's going to be 1,920 pi inches. So every 10 seconds, okay, think about this tire, there's going to be 1,920 pi inches that is going to be rotating, or revolving here, covering the ground. Okay, so that's the arc length that we're going to be dealing with here. So using our formula, we just calculated arc length. We're going to substitute that in for S. Again, in my problem here, we're dealing with a time of 10 seconds. So the linear speed of this tire is going to be 192 pi inches per second, okay? Which is approximately 603.19 inches per second. Now, if you want to convert this to miles per hour, which might have some more meaning for you, you can do that. I've got some videos on dimensional analysis that you can watch. But for now, just because we were asked to find the linear speed in inches per second, that's where we're going to stop, okay? So that's going to be part 1 of the video. We're going to do a second part here to cover example 2.